Today's lesson is on rational expressions. So we're going to start off looking at the domain of a rational expression because all of P5, which is going to take us a few days to get through, we're going to have to check to make sure that we don't have any domain restrictions. Because anytime we have, if you think about rational numbers are fractions, so rational expressions are going to be expressions in fraction form. So with that, we're not allowed to divide by 0, so that therefore we're going to have to check to see if there's any domain restrictions. So there's 3 main things we're going to look at. The first thing we're going to look at, and we must remember that domain is dealing with our x values. So what values of x would make our expression become undefined. So if we are looking at a polynomial expression, so this right here, is an example of a polynomial expression that we've been working with. We have factored these and done other things with them. So if you have a polynomial expression, the domain is all real numbers. And this right here is the symbol for all real numbers. The reason it is all real numbers for all of them is because if you look and say, okay, what am I doing to my x's? Well, this x is being raised to the 4th power, then it's being multiplied by 5. Is there any time where I have a certain number I'm not allowed to raise to the 4th power, or I'm not allowed to multiply by 5? And the answer should be no. I can raise any number, fraction, decimal, anything, whole number, integer. I can raise it to the 4th power. Here, I'm allowed to raise it to the 3rd. I can square any number. I can multiply any number by 7. And that's how all of our polynomials are. So for a polynomial, the domain is all real numbers. The next type of expression we're going to look at is a radical. So we've been looking at radicals before. So remember, the radicand is what is underneath your radical symbol. So if it has an even index, so square root, 4th root, all of those, we need to make sure that what is under the radical symbol is greater than or equal to 0. Because I can't take the square root of a negative. I can't take the 4th root of a negative. So therefore, it would look like this. If we were to write our domain, it would be the domain is x greater than or equal to 0, or all real numbers greater than or equal to 0. And unfortunately, I'm sure you guessed it, they're not just going to have an x under there. It's going to be a whole expression, so that will lead us into a bunch of different things for the rest of the chapter as well. And the last thing we're going to look at, I think you have to maybe fix this. It should not be fractional. For a rational expression, so our fractions, the denominator cannot be 0, okay? The denominator has to be something other than 0. So to try to find the domain for those, or what the restrictions would be on the domain, we set the denominator equal to 0 and solve to try to find what values are going to make that 0. So our first example, we are just going to find the domain of each of these expressions. So for the first one, if we're finding the domain, ask yourself, okay, what type of expression is this? Is it any of those 3 we talked about? And the first answer is yes. It is a polynomial. So since it is a polynomial, my domain is all real numbers. Or you can write out all real numbers. Okay? For part B, we see a radical sign. So anytime you see a radical sign, you take what is underneath your radical. So in this case, we have x minus 2. That's the only thing that's underneath of it. And we set that greater than or equal to 0. And then solve. So to solve it, we're just going to add 2 to both sides. So x is greater than or equal to 2. So that is my domain. That tells me exactly what numbers I can plug in there. So we can say domain is all real numbers greater than or equal to 2. Because if I substitute any numbers in that are less than 2 or exactly 2, exactly 2 will work. Because if I do, hang on a second. If I do 2 minus 2, I get the square root of 0. The square root of 0 is still just 0. Okay? So that's why 2 is included. So if I do anything less than 2, say I substitute in 1. Square root of 1 minus 2, that's the square root of negative 1. And we all know that becomes a complex number than our imaginary number. So we can't do that. Okay? And for our final one, we have a fraction. Okay? I don't care about the numerator. The numerator doesn't make my fraction undefined. What makes the fraction undefined is the denominator. So for this one, we are going to find the value that makes it 0. And I'm sure you all can look at it right now because this is not a difficult equation to solve. Eventually, they will become more difficult. So set them equal to 0 and solve. So add 3. We get x is equal to 3. So this is where we have to be careful, though. That does not mean that 3 is my domain. In this instance, it means my domain is all real numbers not equal to that value, because that is the value that makes my denominator 0. And a denominator of 0 is undefined, cannot divide by 0. So take a few moments. You can pause the video, try these next 3 your turns, and then check back and see how you do. All right, so for this one again, it's a polynomial, so it's all real numbers. For the next one, we have to do a little bit of work. 2x minus 3 is greater than or equal to 0. So I'm going to add 3 and then divide by 2. So this means my domain is all real numbers greater than or equal to 1.5 or 3/2. And for the last one, I'm sure some of you are able to see this. It's a fraction, so we set the denominator equal to 0. So we get 2x equals -1, and x is going to equal -1/2. So my domain is all real numbers not equal to -1/2. Okay, and we are going to revisit domain once we get into later into chapter or section P5. All right, so this little box here sort of summarizes that because we're going to sort of switch gears a little bit and go into simplifying them. So we're going to talk about what rational expressions are. So a rational expression is just when we're dividing 2 polynomial expressions, okay? We need to make sure that they're in simplest form. So simplest form is when the numerator and denominator have no factors in common aside from +1 or -1. Okay, so if they do have common factors, then we need to divide by that, okay, or cancel them out. And I think this should be something you guys did in Algebra 2. So our next example, says write the following rational expression in reduced form. So we are going to combine what we did last week with factoring and see how that evolves till today. So I'm going to, let me see if I can get colors that are sort of the same. I'm going to take care of my top first. And now I know this might not seem that big of a deal because we only have one, but I'll give you a heads up as to what we're going to in the next couple sections. This right here is going to be one problem later, and it's going to require us to keep our work nice, neat, and organized. So we're going to start that process now. So my top one is going to be done in this color. So I have to factor my expressions, okay? Because once they're in factored form, then we can see if they have common factors, and then we're able to reduce. So you factor however you factor. You know, I'm going to use California method. So factors of 12 are 1 and 12, 2 and 6, 3 and 4, and that's all of them. So the combination will be a 2 and a 6, a -2, and a +6. My leading coefficient is just 1, so this factors to x minus 2 times x plus 6. Okay, so I'm going to write that up top over here. X minus 2, x plus 6. Okay. And then we're going to do our denominator. So my denominator is not quite as bad to factor. It's just a binomial, so we just factor out the GCF. So the GCF of this is 3, and we are left with an x minus 2. So I'm going to write that over here. All right, and then we look here and say, hey, do we have any factors that are the same in the numerator and denominator? And our answer is yes. We have an x minus 2 and an x minus 2. So we cross them off, because remember, anything over itself is 1. And then I can write my final answer, part of my final answer, I have an x plus 6 up top all over 3. But now we need to be careful because I crossed off an x minus 2. So if I crossed that off, I can't see from my final answer that we have here that if I substituted 2 into this original problem, I'm going to get a denominator of 0. Because if I substitute 2 in here, I get 3 times 2, which is 6. 6 minus 6 is 0, which is undefined. And I can't tell that from my final answer. So what we have to do is we have to state our domain restrictions. So anytime you cancel something from your denominator, you set that equal to 0 and solve it. So x equals 2. That means that's my domain restrictions. So we're going to expand our solution just a little bit and say, hey, my answer is x plus 6 divided by 3. And then we usually put like a semicolon there. Then we say x cannot equal, and then whatever value. And sometimes it is more than one value. Sometimes it's 2 or 3, depending on what we cancel. And then that's your final answer. So hopefully you did some of this last year. But again, pause the video, try this one, and then come back and double check. Okay, so I'm going to factor the first one. This one, well, I'll do the work. So x squared minus 2x plus 1. The only factors of 1 are 1 and 1. And in this case, they both have to be negative. So this is a perfect square trinomial. But I told you I always forget about those. Okay, so that's my numerator. X minus 1 times x minus 1. And then our denominator is difference of squares. So that factors to x plus 1 times x minus 1. So we're going to write that down here. And then we look and say, okay, is there anything I can cancel? We say yes, we can cancel one of those. So my final answer is going to be x minus 1 in the numerator all over x plus 1 in the denominator. But don't forget, x cannot equal what number? So we set that equal to 0, and x cannot equal 1. And that's our final answer. Okay, so hopefully this is making sense to you. You don't mind the factoring. All right, we just have 2 more examples and then a your turn. There's really no big difference here, just trying to show you different things you might run into. So for this one, in the numerator, it's difference of squares, so I'm just going to go ahead and factor it. X plus 5 times x minus 5. And then my denominator, I can't really do anything to that, so I'm just going to write 5 minus x. Now, if you're looking at this and thinking, hey, these two look very close to one another. You are correct. They are very close, but I can't cancel them the way they are because they're not exactly the same. But what I can do is in my denominator, I can pull out a negative 1 because then that will switch the sign of everything. So it made my 5 a negative, so I wrote that second, and then made my x a positive, so I just wrote it first because I like writing the x values first. But now we can see, hey, these two things here will cancel. So then I can rewrite it as x plus 5 over negative 1, but that's not the best way. So I'm going to do negative times the quantity x plus 5. But then don't forget, x cannot equal, it should be 5. So x cannot equal 5. And that's our final answer for there. So the only difference here is don't forget, sometimes you might have to factor out a negative 1. All right. Now for this one. You factored problems like the numerator before. I will sort of move this over here. So what I'm going to do, I want my x squared term first, so I'm going to write that first. So negative x squared plus x plus 12. Then I'm going to factor out a negative 1. So it becomes positive x squared minus x minus 12. And then this is going to factor to x minus 4 and x plus 3. So you can factor it whatever method you'd like to. Okay, so that is now factored form, so I'm going to write that up top here. Sorry, I don't know why my screen keeps moving today. So I get negative 1 times x minus 4 times x plus 3. And now let's factor the denominator. Okay, so factoring this guy is not going to be quite as fun. So we need two numbers to add to negative 9, but multiply, oh my goodness, to 8. So factors of 8 are 1 and 8, 2 and 4. The only ones that will work are 1 and 8. So they both need to be negative to get a negative 9. Okay, so my my leading coefficient was not a 1, so I have to actually do this process now. My first fraction I cannot reduce. My second one I can, though. So that's what we're going with. And I'm just going to write that up here. So I get a 2x minus 1, and then an x minus 4. And we say, oh, okay, something can be canceled. So we're going to cross that off. And then we can write our final answer. So a negative 1, or you just put a negative out front, x plus 3. And I know a question I get is, should you distribute that? My answer is no, because in order to see that everything is completely factored, you leave these in factored form. Don't distribute or FOIL or do any of that. And then your denominator is just 2x minus 1. Now again, don't forget, we cross something off, so we have to set that equal to 0 to find out what my restrictions are, and then we say, hey, x cannot equal 4. Okay, because we can't see it in our final answer, excuse me, but if you were to plug that back into the beginning, you would get 0 in the denominator, which we cannot have. All right, so you guys have one last one to do, so pause the video, try it, and then you'll be able to start your practice work. So for my numerator, it is difference of squares. So x plus 3 times x minus 3. The denominator, hopefully you guys remember that, factor by grouping. So it becomes x cubed plus x squared. And then inside parentheses always a plus, and then negative 9x minus 9. So I'm going to factor out an x squared here. I'm left with x plus 1. Here I'm going to factor out a negative 9. Again, left with x plus 1, which is good since they're the same. I'm going to write that down. And then, whoops, factor that. Oh, but be careful here. X squared minus 9, that's difference of squares. And if you notice that from the start, whoops, I already got a plus. You can just cancel them. Since I already factored the top, I'm just going to go ahead and factor the bottom. All right, so now rewriting this in fraction form. I have x plus 3 times x minus 3 in the numerator. My denominator sort along. So I have x plus 1 times x plus 3 times x minus 3. And we look and say, hey, my plus 3's cancel and my minus 3's cancel. So what I'm left with then is just a 1 in the numerator. Don't forget that. I can't just move something from the denominator to the top. So 1 over x plus 1. But now I crossed off two things. So we have to set each of them equal. So x plus 3 equals 0. So x cannot equal negative 3. And then if I do the minus 3 equals 0, x cannot equal positive 3. So over here we can write x cannot equal plus or minus 3. That's our final answer there. So again, hopefully this makes sense. The biggest takeaways from today: can't divide by 0, so remember that domain restriction and factor as much as you can, okay?